Hey everyone, this is Mrs. Lewis. I'm just going to do a quick physiology, a little bit of anatomy review for you guys because we just don't have time with regular lecture, and it's really important to kind of understand a little bit about the kidney so you can understand the disease process. We don't have time to go really in depth. I mean, we could spend probably over an hour, but I'm not. I'm going to try to make this as quick as possible just to kind of help you understand it a little bit more so that you can understand when we're talking about some of the problems. So it's very important to understand the normal so that you can understand the abnormal, right? So let's talk about the normal. You've got a kidney here. I like this picture because you can actually see some of the anatomy there and where it sits. And then I like the fact that it shows you the breakdown of it here with the other picture. So you've got a nephron in the kidney, and the nephron filters the blood, removing waste to be excreted in the urine while absorbing or reabsorbing desired materials such as glucose, amino acids, electrolytes. Regulates fluid balance. So we maintain homeostasis this way. It regulates blood and pH by secreting hydrogen ions. And it regulates the amount of bicarb in the blood. It produces erythropoietin to stimulate red blood cells. So as you can see, the nephron is busy. It's very vascular, as you can see. And these microscopic units that filter, called the glomerulus, that sit there in Bowman's capsule, they are also very vascular. And if you think about it, the reason chronic kidney takes so long to show signs and symptoms is our body was created with all of these nephrons, like 1 million in our body. And within each nephron is this vascular, vascular intricacies to withstand some damage. But over time, if you've got high blood pressure, or you've got diabetes, you can imagine they attack the vessels, right? So with high blood pressure, you've got constriction, which can damage the vessels. With diabetes, you can have some, neuropathy. That damages the vessels. And then think about the glucose that just sits in the blood that damages vessels and will damage the kidneys over time. So that's why a lot of times people don't even realize that they have this damage until there's significant damage. And another reason why it's amazing is it filters and about 1,200 milliliters a minute. That is amazing. So about 1/4 of the normal cardiac output flows into the kidney from the right and left renal arteries. So that is amazing as well, the amount of blood that it filters. You've got your ureters that transport urine from the kidneys or your ureters, some people call them, into the urinary bladder. And then your bladder, and then your urethra. And remember, your urethra is shorter in females and longer in males, hence the reason why when you're putting in a Foley catheter on males, you seem to forever push it in. And so we've got the glomerulus and the nephron here, and that is where all the magic happens. That is the functioning unit of your kidney. Let's talk a little bit about what it does, a little bit more about what it does. It secretes, like I said, we already talked about some of the things that it secretes, and then it also reabsorbs where needed, and it excretes. Now, most of your people that aren't medically trained, they think that the kidneys just get rid of water. And some people may know that they get rid of waste. But we, as medical professionals, know that they do so much more. Let's talk a little bit about the hormones and secretion. So we've got erythropoietin, and erythropoietin is a hormone, right? It's released from the kidney in response to hypoxic states, meaning lack of oxygen, caused by a reduced number of red blood cells. So this hormone stimulates the bone marrow to produce red blood cells. So if there's damage to the kidney, you'll see in chronic renal failure, you'll see anemia because the kidney is not stimulating, the hormone's not being stimulated to produce those red blood cells because there's damage in the kidney. And then let's not forget about calcitrol. It's the activated form of vitamin D, and it's needed for absorption of calcium from the foods that we ingest via the GI tract. So if the kidney's damaged and it cannot secrete the calcitrol, we've got another problem. And then, last but definitely not least, is your renin. Your renin is released from your juxtaglomerular cells in response to blood flow to the glomeruli of the kidney. And this leads to your angiotensinogen in the liver converting to angiotensin 1. Then in the lungs, angiotensin converting enzyme converts angiotensin 1 to angiotensin 2. So that is what renin and aldosterone and ADH play a big part in this as well, right? As you know, and this should be a review, but we'll talk a little bit about it. You've got let's talk about aldosterone first. It's just a mineralocorticoid from the adrenal cortex. And its action is increased sodium reabsorption, therefore then will increase serum osmolality. Water follows sodium, so you get increased blood volume, increased blood pressure. That's your aldosterone, right? And then your ADH is released by the postpituitary in response to increased serum osmolality. ADH is antidiuretic, right? So your response from that is intravascularly dry. Well, let's talk about ADH a little bit more. What it causes the distal tubules to increase water absorption, right? Water absorption. So if the tubules are damaged and they're less responsive to your ADH, you're going to have impaired concentrating ability of the kidney. So what do I say when I say concentrating? Well, concentrating is, if you think of concentrated urine, you think of increased solutes, right? Well, if it's not concentrated and it's dilute, you have more water. So if there's damage there to those tubules, that's what, when we talk about that they're not able to concentrate the urine, that's what we're talking about. They're not able to concentrate the urine, so you're going to get a lot of water and all your electrolytes might be off. And then we've got epinephrine. Epinephrine is basically, remember, it's your fight or flight. And say your fight or flight kicks in, it causes your arterioles to constrict, so therefore you'll get decreased urine production. And it also activates the RAS system. Renin to shunt the blood to all your vital organs, right? And you're being chased by a bear, you don't need to have the urge to go pee, so you need all that blood helping you run. So that's a little bit of how the hormones in the kidney and epinephrine are connected. Oh, and let's don't forget about peptides. Natriuretic peptides are secreted by the heart cells in response to increased blood volume. So they're kind of an antagonist to the effects of your antidiuretic hormone and aldosterone. But these peptides can cause natriuresis, which is just a natural diuresis. for the excretion of sodium in the urine. Your ANP, which is your atrial natriuretic peptide, released from the atrium, and your BNP is released from the ventricles. So these peptides are affected by the renal system as well, as you can see. So just remember that both your aldosterone and your ADH tell your kidney to put water back in the blood. Both work in the collecting duct. So just remember, your ADH causes it to take up the water, and your aldosterone tells it to take up salt, and then water follows salt. So that's just a little bit more. Maybe that'll help you remember it. But that's how the kidneys are affected in the system. So, like I said, understanding the normal helps you understand the abnormal. All right, I have another picture here, and it is a little overwhelming. Hopefully not too overwhelming for you. So you've got your kidney here. You got your blood coming in through the renal artery, and then your blood goes back out after it goes through this whole process here. It goes, it comes back out of the kidney through the renal vein, up through the inferior vena cava, back to the heart. Okay, but let's talk about this whole busy process here. You got blood coming in to the renal artery through your efferent arteriole, and then around to your filtration process there in your glomerulus. Now, you see, this is blood, right? This is blood that's going through all this, and you've got all of these processes going on. Your distal tubule, where your reabsorption of water and excretion of potassium and hydrogen ions and ammonia, and then you've got these capillaries, these tubular capillaries as well. Remember, it says very vascular, and then as it goes down through the proximal tubule, you've got the reabsorption of electrolytes and amino acids and bicarb and water. So it goes on around, and you've got the loop of Henle, where it can be concentrated. It concentrates there, reabsorbs water, sodium and chloride. And just remember that the collecting duct is reabsorption of water. It is, ADH is required, so the antidiuretic hormone, remember we talked about how the antidiuretic hormone is key in this, and it's the collecting duct, so therefore then you've got your water that goes to your ureter and your bladder. So think about, you've got, a very intricate system here where you've got blood going in, things, being filtered, and then it going back out into the body. You've got also a process of water being filtered, and hormones being secreted, and the reabsorption of water and electrolytes and amino acids and bicarb. So all of this process is happening, and if there's damage here to this glomerulus, you've got a problem. If there's damage to the tubules, you got a problem. And like I said, there's lots of these, but if over time lots of them are damaged, then you're gonna start to see problems. And that's all I have. I wanted to give you a closer picture of what all goes on in the kidney, so that you could just understand when something's wrong. And when we talk about, the kidney can release the water, but it can't concentrate the urine. Well, there's damage. It's because of damage, right? So these things, you know, it's good to just review and have a understanding. Like I said, we could go on for an hour and go really in depth, but I didn't feel like, you know, you needed that. If you specialize or if you want to, Khan Academy's got some great stuff out there if you want to get really in depth. And anyway, we'll talk about acute kidney injury and chronic next. So hope you have a great day. You take care.